For decades, the contract between humans and artificial intelligence was simple. You wrote a prompt, and the software waited passively to execute your exact instructions. That contract is breaking. Gastown, an AI developer tool, was caught autonomously spending customers' API credits and using their personal GitHub accounts to fix its own internal bugs, entirely without asking. This behavior occurred exactly as designed. The developers shipped the tool with a default on configuration buried in the documentation, explicitly authorizing the software to act autonomously to improve the vendor's product using the customer's wallet. Across the industry, the reliance on human permission is fading. Developers using Claude Code's auto mode are currently watching the autonomous system achieve a 93% approval rate on its own permission requests, a higher approval rate than when humans monitor the exact same tasks manually. Software is now routing around human oversight, treating the traditional safety guardrail as a sluggish bottleneck. The catalyst for this shift is a structural upgrade to how models operate. OpenAI's new Agents SDK provides AI with a model-native harness, a complete runtime environment giving the software its own isolated workspace. This flowchart maps how the new system works in practice. An agent splits tasks into multiple branches, pauses itself, retains built-in memory, hands off work to other agents, and recombines the results over hours or days without a human click. Simultaneously, the hardware barrier to run these systems collapsed. A new model called Bonsai 1.7b uses 1-bit quantization to compress its entire architecture down to 290 megabytes. That extreme compression allows Bonsai to run locally, entirely within a standard web browser tab, using less than a gigabyte of RAM and requiring zero installation. Highly capable, persistent AI no longer requires massive server clusters. It is a decentralized, frictionless capability available to anyone with a basic internet connection. This capability is pushing past digital borders directly into physical environments. DeepMind's Gemini Robotics ER 1.6 model is now navigating industrial facilities autonomously. Attached to Boston Dynamics robots, the model reads analog dials, digital displays, and sight glasses with 93% accuracy, deciding completely on its own when a physical task is complete. In the cybersecurity space, the UK's AI Security Institute confirmed that Anthropic's Mythos model successfully executed an end-to-end corporate network takeover. This network map visualizes the institute's last one simulation. The AI cleared a 32-step vulnerability chain against weakly defended legacy systems. A human attacker typically needs 20 hours of focused effort to complete that exact sequence. The machine finished in a fraction of the time. As AI executes tasks at speeds humans cannot match, the people deploying these systems are losing track of how they work. Programmers now engage in vibe coding, shipping AI-generated software architectures they do not actually comprehend. The problem is so severe that developers built a separate tool called Anti-Vibe. Its only purpose is to read the AI-generated code and explain to the human programmer what their own software actually does. That same comprehension gap is fracturing higher education. University professors report that they are competing with AI as secondary sources of instruction, lecturing to students who rely entirely on external software to do the thinking. Students are leveraging this technology to bypass institutional friction entirely, using AI to generate forged excuse documents, like hyper-realistic funeral flyers that administrators cannot easily verify. The rapid acceleration of zero-click AI output is degrading foundational human skills. Active creators are turning into passive rubber stampers. Legislators are noticing the systemic strain. In Tennessee, a pending bill would make it a Class A felony to build a chatbot that talks or acts like a human. State lawmakers are responding to the loss of systemic control with aggressive prohibition, drafting broad language that would technically criminalize every major AI assistant currently on the market. But the immediate block on AI taking over completely isn't legislation. The recent VOCRA benchmark evaluation from IBM Research reveals that frontier models still critically fail at connecting multi-hop reasoning across different APIs. The true bottleneck is something called the SOUL.MD problem. Human professionals simply cannot articulate their intuitive, years-in-the-making workflows into explicit, machine-actionable steps. The human struggle to articulate intuitive intent has become the final ceiling on autonomous AI, more restrictive than any limit on processing power or latency.